Hi and welcome to assignment 15 of topic 3, in which the focus will be on implementing an already given algorithm. So we're not expecting you to know this algorithm or find the algorithm. It's just a given and you have to implement it, so meaning you have to translate it to JavaScript. The exercise will be about calculating the greatest common divisor between two numbers of two numbers, and you can safely assume there are going to be two positive integers given, so no need to check for that. I have set up already the input again, so we read two lines of input, parse it or parse both to an int and store them in two number variables a and b. So what about the algorithm? I'm going to show you an example of how the algorithm works, and then from that we're going to try to implement it. I'm going to use comments to do a little writing. Let's assume that I have two numbers. Let's call this the greatest number, or the biggest number, and the smallest number. And let's assume that we're going to be given 15 and 12. What I'm going to do is calculate the remainder if I divide the biggest by the smallest. And that's of course done in JavaScript with an expression like this. So this will be, give me the remainder if I divide the biggest one by the smallest one. And in this case 15 divided by 12 gives me a remainder of 3. And then I'm going to shift to the left all those numbers. So 12 is going to be written into biggest, 3 is going to be written in smallest, and I'm going to do the same calculation. In this case, 12 divided by 3 gives me an integer 4 and a 0 remainder. Now the algorithm says as soon as I have a remainder of 0, that the smallest number will be the greatest common divisor, and that's exactly what this is. 3 is the greatest common divisor of 15 and 12. Let's figure it out. 15 has 1, 3, 5, and 15 as divisors. Well, 12 has 1, 2, 3, 4, 6, and 12. And indeed, the biggest common divisor is not 4, 6, and 12, because these are not divisors of 15, but 3 is the biggest one that they have in common. Now, let's calculate, or better, let's implement this in JavaScript. What I have to do is actually calculate the remainder. So let R be the remainder of A divided by B. And while this remainder is bigger than 0, I will do the shift. So meaning, I can call this biggest and smallest. Okay. Voila. So divide the biggest by the smallest, calculate the remainder. So now I can safely shift the smallest to the biggest. Okay. And then the smallest becomes, well, again, the calculation of the remainder of smallest versus biggest. And that's it. Okay. Finally, this loop will stop when R becomes 0. So you could say while R is not equal to 0. And then I can just print the smallest one. Okay. Let's run this to see, or run the tests to see if I'm good to go. I'm not. So I have something strange here, line, probably something yes, indeed, the code pilot left by mistake. So there we go. We have a little problem here. First one, however, works. Okay, and we have some timeouts now. So if we look at the tests, greatest common divisor of 225 and 15 is 15, and the other way around. And 12, 15, 15 and 12, these are failing, all of them. So let's see why. And then the greatest common divisor of the same number I've given twice is just the number, of course, and that's turning green. But now let's see what's happening with these. That's a timeout of 2000 milliseconds. So something must be wrong here. Let's see. Okay, so this is a good opportunity to show the debugger once more. And let's see what happens if we run this test, right? So this is going to be this test. I'm going to debug it. First, let's add a little breakpoint here. And now I'm going to debug this test. First one turning red. And let's see what's going on. So I have two numbers, 15 and 225, biggest and smallest. So now let's see what's happening. I'm calculating the remainder. You might say, well, I found the problem because 15 is not the biggest and 225 is not the smallest. So wouldn't I need an if here to just swap those two? See, one of the very first exercises we made. So something like this. If the smallest happens to be big, or the biggest, the bigger one actually is smaller than the smallest, then I have them in the wrong order. So I could say I have some temporary variable, or C, like we did in the warm-up exercises, becomes B, and then B becomes S, and then S becomes C. So this is just the swap trick we've seen in one of in the first topic, I guess. So let's run this test again. And it's, well, no, I just want to run it. And this gives me another problem, okay? And no, this is about the debugger. So I'm just going to try to run it now, the test. And now it's turning red, okay? So this is about, I guess, switching numbers. But then again, what happens is, if I have 12 as the biggest and 15 as the smallest, then what happens here? You might wonder, well, what is happening there? If I divide 12 by 15, 15 goes 0 times in 12, and the remainder will be 15. I have to still add 15 to get up to 15. So 15 is 0 times 12 plus 15. And if I do this correctly, am I right? 12 divided by 15. Sorry, 12. I was thinking indeed. So 12 is 0 times 15 plus 12. And if you watch carefully now, what happens is this is just one other loop in the algorithm, because if you shift, then the 15 goes to biggest and 12 goes to smallest. So this is a nice example of where you have to focus on the happy path first, and then by accident you get the exceptional path, the specific path with which biggest and smallest would happen to be the other way around, given the inputs. Things just fall into place, and you don't have to program anything out of the ordinary. But then why did I do or need to do this to run the tests green? Well, let's just figure it out. Okay, so I'm going to take it out again, because on the blackboard I see that things should just get alright by doing nothing. Okay, just one added run through the loop. So let's again focus on the breakpoint here, and then run the case with the debug. So what's happening? B is 15, S is 225. I'm going to calculate the remainder. Okay, remainder is 15 indeed. So this is not 0. I'm going to shift S into biggest. Okay, and smallest now will be the remainder of biggest divided by smallest, and smallest will now be 0. Okay, and then I of course need to print the biggest in this case. Oh no, I remember, I know what I'm doing wrong. I have to of course shift the remainder and then calculate a new remainder. Okay, that's my problem here. Okay, so I can't just overwrite S with something that hasn't changed, because S hasn't changed yet. So if I wrote it like this, okay, the problem is that S hasn't changed when I start to calculate S anew. So that would be a mistake, of course. Okay, so first I have to change S, which is of course the remainder. I'm switching over the remainder to S, and then I calculate the new one. So the new remainder would be again biggest divided by smallest, and get me the remainder. Okay, so this should be looking good now. Let's run them all. And yes, there we go. So I don't need special cases. Just go for the happy path first, and sometimes everything just falls into place. So as a takeaway from this exercise, happy path first, then sometimes you just get special cases for free. What we did was we learned about the algorithm. You're not supposed to come up with algorithms like this. It's the prerogative of mathematicians, but once given or explained the algorithm, you should be able to translate it to JavaScript. Okay, and I just was wrong here because the shifting needed to be done in 2 steps. So smallest being shifted to biggest, that's this one, then the remainder being shifted to smallest. Okay, and then I can start calculating a new remainder, and I of course had to start off with calculating a remainder to begin with, because I have to loop until this remainder is 0. Okay, let's run the test one more time, and everything is okay. Now you might wonder, how much is this an optimization, and what would happen if we didn't know about the algorithm? I'm going to, in a separate video, take you with me on a journey to calculate the greatest common divisor without using Euclid's algorithm. That's not going to be the most optimized version of calculating this, as we will find out, but it's a very nice exercise trying to practice on loops and ifs and so on. Okay, so we'll take it in another video, doing this same exercise brute force. So calculating all the divisors, and then find the common ones, and then find the biggest one, and so on. And well, we'll find out that you can optimize a little bit, but this is nowhere going to be near as beautiful and optimized as this little algorithm here. It's a real gem. See you in the next video, and let's compare them.